Good evening everyone, and we are here with a lesson on MathCAD. You see, MathCAD is a versatile mathematical software in which you can just plot graphs, carry out integrations, differentiation, everything. Now, in order to start, let's start with a algebraic equation. Suppose we are willing to find out a equation or a plot corresponding to an algebraic equation. Now, algebraic equation, suppose y is equal to 2x square plus 3. So, y is dependent on x. So, put y as a function of x as we put in function. Then put colon and it will give you a symbol like this. Okay. Y is equal to 2x square. 2 into x and go to this math operators here. 2x square. Now, right arrow, it will come here, 2x square plus 3. So, this is your function. Well, so far we have got the function, but we don't know what is the range of x or range of x for which we have to find the y. So, x will be, before you define the function, put here x, okay, that's better. X colon, it starts from 0 with an increment. So, we put a comma. Increment means how much it increases. Suppose say 0.1, 0.1, and how far does it go? It goes to suppose say 5. Okay, so it's defined. Now you want to check what, because many times what happens, you take the data from here and put in origin. So you just write here x, then put an equal to, and it will give you all the values of x. Now let me reduce my screen size or else will not be able to cope up. Okay, so it is x. Now let's put y. What would be the value of y? Bracket x. By the way, let me tell you, this first bracket, we often call it, is known as parenthesis, okay, in real time, and bracket is the third bracket that we use, and the second bracket that we call is called braces. So you put equal to, so these are your range. Now you want to plot y versus x. So go to plots, insert plot, xy plot. Just from here. So in the x-axis you put x. In the y-axis you say y parenthesis x. You see, it's a parabolic equation and goes as a parabolic curve. Okay. Now this is very beautifully done. Now there are certain limitations which you should keep in mind while solving. Suppose you have an equation like, so it is your equation, it is done. Suppose I change right now here to minus. Let me see, how does it change? It starts from a minus 3 value, you see. So if it is x cube, basically if we want to put a cube, it is a cube curve, cubic curve. Now if it is a fraction, suppose say 1.3, this is an equation. So it's between 1 and 1 square, parabolic. It's less than a parabolic, equal to slope. Now come to this expression. Suppose you have a function like this, sin x by x. Sin x by x. Okay. So you see, it is not giving. Why? Can you say? Because for the point 0, it becomes 0 by 0, undefined. So if I just change it to point 0, 1, say. Let me check. Well, it's also not coming. Why? Okay, let's change it. 0.05. Probably it's due to the sin x by x term. Now there are certain errors, you can just check it. Okay, sin of x, they had asked here, and you see, sin x, as we write, it is not a function, because sin of x is a function. We often miss this term. Now sin of x, you see, if you put it from here to here, now suppose I want to check it from -5 -5 with increment 0.1, so it becomes minus 4.99. 4.99. Well, it's graph like this. Well, let's change it. I think -5, comma minus 4.99. I just missed it. Minus 4.99, and then it goes to 5. You see, this is the similar to the graph that we often observe in diffraction. So it's called a sinc graph. S-I-N-C, sinc, sin x by x. Now if we want to carry out this expression, probably they have got, oh, this is not showing because at the point 0, 0, 0, you see, there we get a singularity, 0 by 0. At point x is equal to 0, we get a 0 by 0. So it is not showing you. Okay. So in MATLAB, we can just get that point escaped. Here also that is escaped, we get the plots, but the expression. Now suppose we get into another expression. Suppose, as we have said, that we can also carry out some sine function. Go for a sinusoidal function. Okay, let's take a ddx function. It's a ddx function, derivative, or some kind of trigonometric function. Trigonometric function. Okay, so you just write here yx is equal to, suppose, it's sine of x plus cos of x. You see, sin x plus cos x. So it's giving you a trigonometric function. Now if I add a algebraic function over here, suppose x square. You see here x to the power y, so you just put it x square. It's a different thing. See, the sinusoidal curve with an algebraic function as a this parabolic function gives you a majorly parabolic. But it's the same thing if suppose I take this thing within bracket and then multiply it. You see, it's a parabolic function with a multiplicating thing. So how your function changes, how your behavior changes, you can just study with this equation. Now suppose you are given a graph similar to this. Now from your initial idea you can say that, well, there are 2 points of intersection, okay, somewhere like here. So it's square, so there will be more than 2 points, so it will be a quadratic equation or something like that. So in this way you can carry out a lot of calculations in MathCAD. So suppose it is my dispersion relation. Suppose y is equal to omega, as we all omega as a function of k. So it is 1 plus 2x square plus 3x cube plus, if it is a fourth order equation, so it will be 4x to the power 4, and you get an expression like this. You see why? Because we have taken very higher orders of, but if we multiply it with suppose 0.4, let's check, it changes because all these coefficients have different combination to give you different roots. So I remove this thing, the roots gets changed. Similarly, it is 0.3. See, change it. It again comes like this because there was this cube which was very much dominating. Now I reduced it by 1/10, so its behavior is less. Okay. Now if I put it 20 instead of 2, you see it will be more of a parabolic curve. You see, more of a parabolic. Now depending upon these terms, you can say which one is determining, which one is more effective. Now as you deal with your problems, you are, in many cases you are given an experimental data. Okay, in such an experimental data, what you find that you have to fit the graph. Well, there are many softwares these days, but initially there was no software, so a person's intuition was what mattered the most. So as we just see that MathCAD is very much easy, and if you know a bit of programming, you can also put a loop, else, if else, break all these commands. You can also write some symbolic expressions. If suppose your expression is not in terms of xy, it is some omega, epsilon, sigma, so you can just take your equations. So okay, let's give an example. Select everyone, delete. Now we are going to plot a dispersion curve. Now the dispersion curve, as we have said, is omega square is equal to 1 plus k square plus some constant, suppose say 2, or suppose say h, k to the power 4. So the expression initially was something like this, omega square. So you put here omega, where is omega? Omega is function of k, omega square. So there was omega square, so we will write here under root equals to under root square root of 1 plus k square, 1 plus k square plus h k to the power 4. Now you see here it becomes red. Why it becomes red? Because h has not been defined previously. Well, Very good. So first let me define the constants. H equals to, suppose say take a numerical value 2, equals to 2 colon 2, fine. Now the range of k varies from, suppose say 0 to some values. So k colon varies from 0 comma 0.1 colon, suppose say 4. 4. Okay. It was showing red because I didn't put the product sign. Put a product sign. Well done. Now I am not doing again for a k. Now I will just write here. If you want to escape that, I can copy here. Okay. It's better if you just do it like this. Omega bracket k bracket close equal to. Okay. Now I want to plot this dispersion relation, linear dispersion relation. XY plot, go here, put here k, we are happy to put here y, that is y is equal to omega k. Go to math, go to symbol, go to omega bracket k. You see, this is one of the graphs. Now it is a plasma mode, that is, we said there was one acoustic mode and there was one plasma mode. So it's a high frequency, it starts from 1, because from the expression you can see it starts from 1. Okay, and like this we can get our different plots. Now for the same expression, if you suppose h is equal to, h is a parameter, now if h is suppose say 3, just look at the graph how it changes. It changes. So it's moving on the right hand side. Slope is decreasing. So if it is 5, slope is decreasing more. But h has got certain, every parameter has got some range. So if we just mind those ranges, then we can suppose, for instance, h varies from 1 to 2.5. 1, it is in classical case. So it's 1 to 2. So like this, you can use MathCAD to get the graphs. For instance, you want to copy this. You just put this thing. You just select this and right click over here. Copy. And when you open the origin window, you put there. So we are going to show this in a next lecture. So till then,